All right, students, so we are graphing rational functions by transformations. We are taking these graphs, we are taking these functions, we are graphing them, we are making a table, and then once we have the parent function, we're really doing transformations, right? So we're shifting the whole graph up, down, left, or right. There's more transformations, but for our class in Algebra 1, we're only doing up, down, left, right. So first, I would like to mention this is in your book, so if for whatever reason you're unable to understand me, I'm sick right now, or you would like some extra practice, there is a section in your book. You can look it up. If you can't find it, email me. You can also ask the teacher who's there if they can help. So first part we're going to do is look at the domain of each rational function. So remember before we talked about our restrictions, and in the past we've said our restrictions are numbers that would make our denominator be equal to 0, right? Because I can't divide by 0. So if my denominator is 0, I end up undefined because I can't divide by 0. So for this rational function, my domain would be all x values in our real number system such that x is not equal to 3. So this is how we would write it, and this is how you're expected to write it. So pay attention to the notation. Yes, it must look like this. If it doesn't, it is wrong. So please pay attention to the notation. You're going to try this new notation. Okay, we're going to go through these. Oh, I kind of revealed some of the answers. Oops. All right, the next one. All x values in the real number system, the domain, except I can't have -3 and 3, right? Because those numbers would cause my denominator to be a 0, which would give me an error of divide by 0. It's undefined. Okay, for C, I have all x values such that x is in the real number system. There's no other restriction. So it's really just all x values in the real number system, which is kind of nice. And that notation is like that as well. Oops. Go ahead, try to do the second 3 problems. I kind of accidentally revealed the answer a little bit. If you saw a peek, that's all right. Go ahead, do these 3 problems down here. You can pause the video if you'd like to follow along. All right, here's your answer reveal. Ta-da! How'd you do? What do you think? These ones. How'd you do on those? Hopefully all right. Okay. If you have any questions, feel free to email me. Let me know. We're going to continue on here. All right, next up. Graphing rational functions. So what's going to happen is when we have these rational functions, this is what the graph ultimately looks like. We're going to set this up and we're going to graph these. So actually, let me put them back here. All right, so first thing we're going to do is make a table. Here, I'll just start from scratch. So first thing we're going to do is make a table, x, y. I'll plug in my set of numbers that I typically always use, right? Center of my graph. And if I have f of x is equal to 1 over x, if I plug in -2, what's going to happen there? I'm going to end up with -1/2. If I plug in -1, I should get 1 over -1, which is just -1. If I plug in 0, I get undefined. Yikes. If I plug in 1, I get 1, and 2, I get 1/2. So we're going to plot these points now. -2, -1/2, -1, -1. 0 is undefined. 1, 1, 2, 1/2. And what happens if I plug in, let's try something. What happens if I plug in 1/2? I should get out 2, right? So check it out. This actually connects, my line is crooked. All right, this connects relatively flat. It curves towards your origin there and then kind of flattens back out. Please excuse my slightly curved graph. My hand is not as steady since, I'm a little sick here, but I'm trying. So here we go. We're putting these curves on the graph. Okay. And remember, we kind of talked about it before. What are these lines that our function is approaching, right? But it doesn't cross. Do you remember what those are called? Hopefully you do. We've talked about them quite a bit. right? These are the asymptotes. So I have x equals 0 and y equals 0. These are my asymptotes. Yeah. Cool. So let's move on. Let's graph f of x is equal to 1 over x squared. G of x is equal to 1 over x squared. So we're going to graph here. Still going to make my table. Same like I just did before. X and y, -2, -1, 0, 1, 2. All right, that'd be 1 over 4. That'd be 1. That'd be undefined. That'd be 1. That'd be 1/4. Okay, so -2, 1/4. Just a little bit. -1, 1. 0 is undefined. 1, 1. 2, 1/4. What would it be to have 1/2 then? 1/2 would be 1 over 1/4, which is 4 actually. Right? So if we look at this curve now, it's going to start relatively flat and it's going to kind of go sharp up. And the other side's going to reflect. It's going to match. So it's going to start relatively sharp up and then come back down. And it's going to get really flat but not quite touch. So we're actually going to have the same here in terms of those dashed lines that we drew, right? Do you remember what we called them again? Start with an A. Right, our asymptotes. So we're going to have our asymptotes. So if I look at these are also what we define for our purposes of transformations. These are our parent functions. So sometimes you'll see these labeled as parent functions. Because what's going to happen is we're going to label now. We're going to take these same graphs and have numbers added to them. And they're going to shift. So I mean physically, you grab the whole graph and you go up, down, and maybe left. Right? And the whole graph would be centered like that now. Or some variation of that. So those would be after transformations. So right now, our domain for these, here we go. I have my domain, all x's in the real numbers, such that x cannot be 0. What about my range? All y in the real numbers, y cannot be 0. I have my horizontal asymptote at y equals 0. And my vertical asymptote at x equals 0. Do you remember which one's which? Yeah, the vertical one is always the up-down. Horizontal is always your left-right. So flat, or you could think tall, maybe. Okay, go ahead and try to label this domain and range here on the right side. Go ahead, try. We practiced this before, but it's a good review. All right, did you get it? You ready? Domain and range. Here it is. Did you get it? Check. See what you got. It was a good practice, huh? Okay, so your book has a nice graphic that I went ahead and copied over, and it shows you how to graph them. It actually tells you that your H and your K, those are your asymptotes. So your graph will remain the same in terms of the pattern, but the asymptotes will move. So it's kind of like if you highlight the whole graph and you shift that function either up, down, left, or right. That's what we're doing. And there are other things like reflections and stretches and compressions, but we're going to handle those in different classes. For now, all we're doing is up, down, left, right. Shift, right? We're doing vertical or horizontal shifts. All right, so here's the first couple. First thing I'm going to do is look at what's happening here, right? With those numbers. So, where's my horizontal asymptote going to move to? And where's my vertical asymptote going to move to? And this might be a little confusing at first. You can scroll up and look. But to kind of give you a hint here, your right here, 1, is always going to be your horizontal asymptote. So this would be your y equals number. And your x equals number is always paired with your x value right here. This is your h number, right? So this tells me that the center of my graph, where my asymptotes meet, is at x equals 2, right there, and y equals 1. So I can draw my asymptotes. There they are. And now I got to graph my curve. So now all I'm doing is copying the curve from my parent function. So let's see. This is the 1 over x squared. So this is the one where they look really, really close and then they don't. So I believe I had 1, 1. And then I had half and 4. So half and 4. Might have been quarter 4 here. A little bit lower. Alright. And I can always plug in these numbers again if I want to make another table. I can do that. So this is what happened. So the 1 over, so we really only have two functions, two main parent functions, right? That's why we call them parent functions. And then what we're doing is we're taking those parent functions and, ooh, that one shouldn't have touched the asymptote. We got a little close there. And we're shifting them up, down, left, right. So in this case, we're shifting up, down, left, right. Okay, go ahead and try the bottom one. You might have already peeked and saw it. That's okay. Go ahead and try this one. Alright, thanks for coming back to us. Here we go. So remember, the 2 is your horizontal asymptote, and the x minus 1, this will be your vertical asymptote. So your graph should look as like this. Then it's 1 over x squared. And we're going to try now to do 1 over x. So we're going to practice this with 1 over x now. So here we go. 1 over x, 1 over x. Alright. So, same thing. Horizontal asymptote, vertical asymptote. So, x is equal to -1. Y is equal to -2. I'm going to graph my asymptotes here. X is equal to -1. There we go. Y is equal to -2 here. Okay, I want them both to be dashed lines. They're asymptotes. Then, this is the 1 over x, right? So my parent function 1 over x started with 1, 1 from the corner of my asymptotes. And then this one kind of matched. It was like half and half. Kind of like to form a curve, right? So it starts kind of flat. Curves on the corner here. That's supposed to be flat. And it ends relatively flat. It technically is not flat because it keeps getting closer and closer to the asymptote, but it doesn't cross it in these cases. And actually there are cases where asymptotes could potentially be crossed, but we cover those much later in a much later course, not now. So for our purposes right now, these asymptotes are not going to be crossed. Just because we're kind of starting out with the basics of this, we're kind of, practicing. This is like probably completely new for something you've ever seen. So we're just starting with these, right? And like I said, as we continue on with Algebra 2 and pre-calculus, you'll get to graphs where you reflect and you stretch and compress. But we're only focusing on horizontal and vertical shifts for today. So that's really the focus. So go ahead and practice with this one right here. Go ahead and practice, and then I'll reveal. Alright, you ready, people? Horizontal asymptote, vertical asymptote. Let's see. So you should have x is equal to -2, y is equal to -1. Your asymptotes, let me copy my graph over here. It should be at y is equal to -1. And x is equal to -2. So there we go. And I got to move my asymptote down a little bit because that's too far tall. Like that. So there's how my graph should look. Yay! So it's pretty similar. It's flipped, right? The 1 and the 2's are actually flipped. Pretty similar there. Cool. So you guys did it. That was it. You did it. Yay! So proud of you. Alright, we're going to go to our partner activity. Hopefully there's still time in the day today. I want you to try with these problems. There's actually a whole bunch of practice problems. Go ahead, try with these, and then try with the next set. And then I have your answer key, but I forgot to write it up. So I'm going to have to scroll all the way to the end and just kind of let you practice with these. Yeah. So go ahead, practice with these for now. Alright, thanks for coming back. And you have a second set as well with graphing. Go ahead, try to do these. And then I'll check your answers for these when we come back to class in person. If you want to see the answers to them right away, you can go ahead and let me know. Send me an email if you want. But otherwise, we'll go over to class. And here's what we have. So these are some extra practice problems. If you want to practice this some more, or you're like, I'm not quite sure, here's all the possible practice problems for the book. You're welcome to practice these. And, all right. You did it. You made it through the lesson. It's time for your assignment. You are welcome to start. Please be kind and polite to everyone. Some people might be taking their time or might be confused with these graphs. It is a new concept for everyone. So if you're someone who understands it and you're like, I got it. I have the pattern memorized. I know what to do. Please be a friend and help someone out. Please don't be rude and distracting others. We do have, I believe, we might have a math teacher who is in the room. You're welcome to ask her for clarification. Or if it ends up being someone who's not math, that's okay. You can send me an email. We do have math lab Monday, so it'll be after school today in room 15. And yeah, thank you so much for listening. I hope to feel better soon, and hopefully I'll be at class next class. Yeah, thank you. Bye, guys.